Welcome to lesson 4.6, analyzing quadratic functions of the form y equals ax squared plus bx plus c. Now that is general form of quadratic equations, and in this lesson we're going to actually investigate how we can determine some properties of the function from the equation in this form. So let's just dive right in. When the quadratic equation is in general form, y equals ax squared plus bx plus c, the constant term c is the y-intercept of the graph of the function. If the equation is factorable, the x-intercepts can be found by factoring. I'll talk about whether or not an equation is factorable when we look at some examples. Now when y equals ax squared plus bx plus c can be written in factored form as y equals a onto x minus x1, x minus x2, then the x-intercepts of the graph are x1 and x2. The x-intercepts are symmetrical about the axis of symmetry, so they can be used to calculate the constant term in the equation of the axis of symmetry. This constant is the mean of the x-intercepts, x1 and x2. So the equation of the axis of symmetry is x equals x1 plus x2 divided by 2. The constant term in the equation of the axis of symmetry is the x-coordinate of the vertex. So the y-coordinate can then be determined by substituting in the equation of the quadratic function. So there are steps that we can take to actually determine what the function looks like from an equation in standard form. Let's check it out through some examples here. Example 1. Identify the intercepts, the equation of the axis of symmetry, and the coordinates of the vertex of the graph y equals negative 2.5x squared minus 7.5x plus 10. Well, first of all, before we even do any calculations, we know that the constant term c here, the plus 10, is the y-intercept. So there is one of our intercepts right away. Now to find the x-intercepts, we need to factor this equation to find our zeros of the function. So here we go. We got y equals negative 2.5 x squared minus 7.5x plus 10. Well, let's factor out that coefficient of negative 2.5 out. And we'll get negative 2.5 onto x squared, now plus 3x, and minus 4 is our new polynomial. And as a matter of fact, we can factor that right away. So we get negative 2.5, and the factors are x plus 4 and x minus 1 in this case. Now, go on ahead and setting those equal to 0, we get x plus 4 equals 0, hence x equals negative 4, and x minus 1 equals 0, and x then equals positive 1. Now here, x equals 4 and x equals 1 are our x-intercepts here. Now from those, we can go ahead and find the axis of symmetry, because the axis of symmetry is the mean of our x-intercepts. So it equals our x1 plus our x2 divided by 2, which are negative 4 and 1, which simplifies to negative 3 over 2. Or we could say negative 1.5 in decimal form. And hence that is our axis of symmetry. But lastly, we need to find our vertex. Well, we already know the x value of the vertex because that comes from the axis of symmetry, and that is negative 1.5. But what is our y value? We don't know that quite yet. So we need to find that. And we find that by taking our x value and plugging in to our original equation. So we get y equals negative 2.5 times 1.5 squared minus 7.5 times 1.5, negative 1.5, plus 10. Now if you go ahead and you take your calculator and you go ahead and find that all out, you're actually going to get a value of 15.625 as your answer. Hence, we can fill in our y value for our vertex as 15.625. And there we go. We now have our vertex as well and all the properties that we were looking for using an equation in general form. Awesome, let's do another one. Example 2, sketch the graph of each quadratic function. So when I say sketch, I want you to go ahead and find some of the properties out from the equation and give me a rough drawing of what it would actually look like. It doesn't have to be perfect, but I want an idea of what it looks like. So part A, we have y equals negative 2x squared plus 10x minus 14. So this is in general form. So in order to find some of the properties in general form, we need to know if it can be factored. So this is where I'm talking about whether or not something is factorable. And we can determine that by using the discriminant of the equation. So if the discriminant b squared minus 4ac equals a perfect square, then the equation is factorable. So let's test that out here in part A. We have b squared is 10 squared minus 4 times a is negative 2 times negative 14. And then we get 100 minus 112, and we get negative 12, which is not a perfect square in this case. So we can't use the equation in general form to help us sketch the graph. We're going to have to put it into standard form. So we need to complete the square in this case. So let's start off by doing that. We have y equals, factoring our negative 2, we get negative 2 onto x squared minus 5x minus our 14. Now completing the square, we get negative 2 onto x squared minus 5x plus 6.25 minus 6.25 with negative 14 on the outside. Bringing this term out, we get negative 2x squared minus 5x plus 6.25. And now we have plus 12.5 minus 14. Now we can simplify, and we're going to have negative 2 onto x minus 2.5 all squared minus 1.5. Now we have our equation in standard form here. So what are some of the properties that we know from there? We know that the vertex is now going to be at 2.5, negative 1.5, and we know that it is also going to be flipped because it's got a negative leading coefficient, and it's being stretched by a factor of 2 in this case. So let's draw our function. We're going to have something like this. And our vertex, so it's in the positive direction. So if this is 2 and 3, this will be about negative 2.5, and then in the negative direction, negative 1.5, we're going to have it somewhere around here. 2.5, negative 1.5. There's our vertex. And since it's flipped, we're going to open downwards, and it's being stretched by a factor 2. So instead of going over 1, up 1, we're going to go over 1, up 2, both sides, and then over 1, up 6. We're going to get way down here. So our graph should look a little like this. Stretched, or vertically, flipped, with a vertex of 2.5, negative 1.5. Awesome. Let's do B now. We got y equals 4x squared plus 4x minus 15. So first things first, is it factorable? Let's see using our discriminant. We get 4 squared minus 4 times negative 15. And we get 16 plus 240, which equals 256. And 256 is a perfect square, so this is factorable. So we can just use it in general form. Let's see what we get. We get y equals 4x squared plus 4x minus 15, which factors using our AC method here. And we got 4 times negative 15, and we get negative 60 in this case. So our factors here are going to be negative 6 and positive 10. So when we rewrite our equation, we'll split the 4x to negative 6x plus 10x minus 15. Now we can go ahead and split our equation, and we'll take out a factor of 2x here, leaving us with 2x minus 3, plus a 5 here, leaving us with 2x minus 3 as well. And hence our factors are 2x minus 3 and 2x plus 5 in this case. Then when we set them equal to 0, we get intercepts of 3/2 and negative 5/2. And these are our x-intercepts. We also found our y-intercept just by looking at our original equation. Remember, our c constant is our y-intercept of negative 15. We can also find out our axis of symmetry, which will give us our vertex. Now remember that our axis of symmetry is the mean of our x-intercepts. So it's going to be x1 plus x2 divided by 2, which gives us 3/2 minus 5/2 divided by 2, which equals negative 1/2. So now our vertex that we have has an x value of negative 1/2. So we can go ahead and plug back into our original equation to find our y value, which will be y equals 4 times negative 1/2 squared plus 4 times negative 1/2 minus 15, which equals 1 minus 2 minus 15, which equals negative 16 now. So we have a vertex of negative 1/2, negative 16. So now we should have enough information to go ahead and sketch out our graph here. See, our vertex is at negative 1/2, and way down at negative 16, say it was down here. Negative 1/2, negative 16, our vertex. And we know that it does open upwards because we have a positive leading coefficient. We have x-intercepts at negative 5/2, which is about there, estimate, and positive 3/2, which is about there. We also have a y-intercept at negative 15, just above, which is about there. So from here, we could go ahead and sketch out our graph that intersects through all these points, like so. And it just keeps going and getting bigger. Voila! That would be the sketch of our graph here. Let's do one more example.